Hello students, welcome back to my channel. Today we'll study the topics of real analysis. That is, there exists a continuous function which is nowhere differentiable. Now let's get started. Theorem. There exists a real continuous function on a real line which is nowhere differentiable. Proof. Define phi of x equal to mod of x for x belonging to -1 to 1 interval and extend to extend phi to whole real line by phi of x plus 2 is equal to phi of x for all x belonging to reals. That is, phi is a periodic function with period 2. अब इसकी अगर रिप्रेजेंटेशन देखनी हो ग्राफ पे, this is a real line, this is y-axis, then 1 -1 -2 2 mod x -1 से 1 इंटरवल के बीच में कैसा होता है ऐसा, where this is 1 and similarly ये रिपीट करता जाएगा क्योंकि ये पीरियोडिक फंक्शन है. Like this, it will repeat. For all s and t belonging to R, phi of s minus phi of t is less than or equal to mod of s minus t. Because if s and t belongs to interval -1, 1 or 1, 3 and so on, s and t belongs to 2n minus 1, 2n plus 1 for n belonging to integers. Phi of s is equal to 2n minus s mod, which in turn implies phi of s minus phi of t mod is equal to mod of 2n minus s minus mod of 2n minus t, which in turn implies s minus t. Therefore, it is less than or equal to s minus t. Therefore, s and t belonging to 0, 2 interval prove phi of s minus phi of t mod is less than or equal to s minus t mod. Then it will be proved for whole reals by periodicity of phi. Now if s and t belongs to both 0, 1, it implies अब अगर हम ग्राफ में देखें तो यहाँ पे ये वाली लाइन x होएगा फंक्शन, ये वाला 2 माइनस एक्स, ये x माइनस 2, एंड सिमिलरली ये 4 माइनस एक्स वेयर दिस इज 4, एंड ये होगा हमारा माइनस ऑफ x। सो 0, 1 के बीच में हमारा x आ रहा है, which in turn implies phi of s minus phi of t का mod is equal to s minus t, in turn is equal to less than or equal to s minus t का mod. Similarly, if s and t both belongs to 1, 2 interval, it would imply phi of s minus phi of t का mod is equal to 2 minus s minus 2 minus t, which is equal to t minus s, which is less than or equal to s minus t का mod. Similarly, if s belongs to 0, 1 and t belongs to 1, 2, a similar proof can be written, and we will get that phi of s minus phi of t is less than or equal to s minus t का mod. In particular, phi is continuous on reals. Why? Because phi of s minus phi of t is less than or equal to s minus t का mod for all s and t belonging to reals. That is, it follows Lipschitz condition, Lipschitz continuous condition. Hence, it is uniformly continuous and therefore it is continuous on reals. Define another function f of x equal to summation infinity from n equal to 0, 3 by 4 raised to power n, phi of 4 raised to power n x. Now, mod 3 by 4 raised to power n, phi of 4 raised to power nx is less than or equal to 3 by 4 raised to power n equal to m n, which in turn implies that summation mn is convergent by Weierstrass M test, that is, series of f is uniformly convergent. As each term is continuous of f is continuous on reals, it implies f is continuous on reals. Fix a real number x and a positive integer m. Put delta by m equal to plus minus half of 4 raised to power minus 1, where sign is chosen such that no integer lies between 4 raised to power mx and 4 raised to power mx plus delta m equal to 4 raised to power mx plus minus half. Since 4 raised to power m delta m का mod is less than is equal to half. Now gamma n is equal to phi of 4 raised to power n x plus delta n minus 5 raised to power 4 raised to power nx over delta m, which implies 0 if n is greater than m and less than or equal to 4 raised to power n if n is less than or equal to m and greater than or equal to 0. 4 raised to power n x plus delta n minus 4 raised to power nx is equal to 4 raised to power n delta n, which in turn implies plus minus half 4 raised to power minus n into 4 raised to power n. Say it is equal to 2k, suppose. So for n greater than m, phi of 4 raised to power n x plus delta m minus phi of 4 raised to power nx is equal to phi of 4 raised to power nx plus 4 raised to power n into delta m we have taken as 2k minus 4 raised to power nx. ये हम as 2k क्यों ले सकते हैं कि यहाँ से 2 इसकी पावर में हम लिख सकते हैं प्लस माइनस 2 रेज टू पावर 2n माइनस 2m माइनस 1. सो इसमें से एक 2 कॉमन ले लेंगे तो हमारा आ जाएगा ये फॉर्म. नाउ अब हमें पता है फाई इज पीरियोडिक विथ 2, सो इट वुड इम्प्लाई phi of 4 raised to power nx minus phi of 4 raised to power nx, which is equal to 0. Now next case, for n less than or equal to m, lambda n gamma n is equal to phi of 4 raised to power n x plus delta m minus phi 4 raised to power nx over delta m is less than or equal to 4 raised to power nx plus 4 raised to power n delta m minus 4 raised to power nx over delta m. ये हम ऐसे क्यों लिख सकते हैं क्योंकि हमने अभी प्रूव किया था कि phi of s minus phi of t का मॉड इज लेस देन इक्वल टू मॉड ऑफ s माइनस t. तो इसमें हमने s ये सपोज कर लिया एंड t ये सपोज कर लिया एंड यहाँ पुट कर दिया. हेंस गामा n का मॉड is less than or equal to 4 raised to power n delta m over delta m का mod. This is equal to 4 raised to power n का mod. In turn implies this is less than or equal to 4 raised to power n, which we need to show. Now what is gamma m is equal to phi of 4 raised to power m x plus delta m minus phi of 4 raised to power mx over delta m is equal to phi of 4 raised to power mx plus minus half, because 4 raised to power m into delta m is plus minus half, minus phi of 4 raised to power mx over delta m. Now we know that no integer lies between 4 raised to power mx plus delta m and 4 raised to power mx. Therefore, they lie on the same line. they क्या है इसमें 4 raised to power m x plus delta m and 4 raised to power m x. अब अगर ये सेम लाइन पे लाई कर रहे हैं so it means that gamma m का mod is equal to 4 raised to power mx plus minus half minus 4 raised to power mx over delta m, which is equal to plus minus half into plus minus 2 over 4 raised to power minus 1, which in turn implies 4 raised to power m. Now mod of fx plus delta m minus f of x over delta m is equal to summation 3 by 4 raised to power n gamma n infinity from n equal to 0 which is greater than or equal to summation 3 raised to power 4 by n gamma n mod, which is greater than or equal to 3 raised to power 4 m gamma m minus summation m minus 1 n equal to 0, 3 by 4 n gamma n, where it is n is equal to 0 till m. मैंने फर्स्ट m टर्म्स ले ली एंड उन फर्स्ट m टर्म्स में से mth टर्म में से बाकी की सारी रेस्ट ऑफ द टर्म्स कट कर दी, तो ये वाली क्वांटिटी तो बड़ी ही होएगी ना इससे। ये समेशन है इन सब टर्म्स का, इस टर्म का और इस टर्म का, और मैंने इसमें से माइनस कर दी इतनी सारी टर्म्स, which in turn is greater than or equal to 3 by 4 m. Gamma m is equal to, we know, 4 raised to power m minus m minus 1 n 0, 3 raised to power 4 raised to power n gamma n, which is greater than or equal to 3 raised to power m minus summation 3 raised to power n, because gamma n हमने प्रूव किया था कि फॉर n less than or equal to m, gamma n is less than or equal to 4 raised to power n, so minus gamma n would be greater than or equal to 4 raised to power minus n. This in turn implies mod of gamma n is greater than or equal to 4 raised to power n. m minus 1 and n equal to 0, which is equal to 3 raised to power m minus 3 raised to power m minus 1. Use geometric series, geometric progression formula, which in turn is equal to 2 into 3 raised to power minus m minus 3 raised to power m plus 1 over 2, which is equal to 3 raised to power m plus 1 by 2. That is mod of fx plus delta m minus f of x over delta m is less than or greater than or equal to 3 raised to power m plus 1 by 2, which in turn implies f is not differentiable at any x.